All right, welcome everyone back to the Sunday morning, my favorite hour of the week, 9 a.m. And as I say always, you guys have been really motivated enough to chuck your sleep off and get in front of the camera. So, what are we going to do today? So, in the last 15 odd sessions, yes, we had 15 sessions so far. Today is the 16th one. And last 15 sessions have been dedicated to algebra. Wow. It was a, it was a mountain to climb. So in this journey, what we've done is that we covered pretty much all, all of key algebra uh, dot points. But that doesn't mean that algebra is finished. Algebra is an ocean. There's a lot more to it. I mean, the deeper you go, the interesting it becomes. But we have to draw a line somewhere, right? Especially, for the exam that you're preparing and at the level that you are. Uh, so I've drawn the line. So algebra is sort of, you know, finished from my end to the point that it should now equip you from a concept standpoint to understand any kind of an exam questions. And we've gone up till year nine, and at times I've touched a bit of a year 10 as well, so you won't be surprised about it. But not too much of. I've just sort of gone and give it a nudge and came. Now, what are we going to do today? We are going to start geometry. So next few sessions will be dedicated to geometry and its core concepts. Now, before we deep dive into trigonometry, which I want to do, after this, geometry is very, very important. Till the time we don't understand triangles, till the time we don't understand angles, till the time we don't understand parallel lines and all sorts of angles that are drawn across parallel lines, understanding trigonometry could be very, very challenging. And hence, we will start with geometry. A lot of you, geometry is one of the most ignored topic of maths. When we do mathematics, a key focus is on algebra, and then there are a few things here and there. And this is one of the most ignored topic, right? So we'll do basic geometry and I'll touch upon every key concept that you need to know in order to one, understand trigonometry as we move forward, including Pythagoras theorem and all that stuff, right? And after that, we'll touch upon those portions of trigonometry which are key for you to learn at this point in time from an exam standpoint. Mind you, exams just round the corner. Another few weeks, you're there, right? I think mid-June is when the exam is, and we are sitting at end of Feb now, so we don't have time, right? Let me quickly check if there's any participant sitting in the waiting room at the moment. No, none. I've let everyone in. 36 of you are in right now. Those who've not been able to join, then probably, it is the link that might be problematic at your end. But anyone who joins in, I get a message and I let them in right straight away. Okay, cool. Now, rules again to reiterate. You before I start the lesson, right? And we know all of it. And in case you're joining it for the first time, all of you are allowed to answer and ask questions on chat when I ask you to do that. Not before, not after. Anyone who is found spamming on the chat, distracting me. So when you spam, you distract me first, right? Because your chat is running on my other screen along with all the education material that I have, that, my lesson plan. So it distracts me. So please don't, you know, force me to send any person who's found spamming back into the waiting room. I don't like it. Learning, this is a hour that we are there to learn. So let's learn together. When I ask you to throw stuff on chat, please do. When I ask you to stop, please stop. So with that thought in mind, let me just share my screen now. And I hope you're able to see my screen. I would want to see a yes or a no on the chat now. Thank you very much. Everyone's able to see my screen. Awesome. And I don't have anyone in the waiting room because the moment I get someone's joining late, I get a pop-up message. All right, let's kick off. So, as I said, today the topic is today is 22nd of Feb 2026, and we are going to learn geometry today. Now, one last thing that I forgot to mention, and I keep mentioning everyone, if you stop hearing me for any reason, it is simply because my Bluetooth has stripped off. So ping me on the chat that I'm not audible, and I'll do some magic and I'll come back, right? In case my Zoom hangs over, technology can play up. Hang in through the session. I might have to reboot my laptop and come back, which means another 5 minutes, and it's a distortion for everyone I know. But I can't, internet, laptop can go wrong. So hang in there, don't panic, and I'll come back, right? And I'll let you in again. I know there could be disruption. Things are not in my hand. All right, let's talk about geometry. So geometry, as I said, is one of the most ignored topic in maths, but geometry is very, very important. It's all around us. Where algebra is called the father of mathematics in terms of it's everywhere, it is acquired everywhere. Geometry is simply the mother. It is, it's it's everywhere as well. So combined geometry and algebra, opens, all the realms of mathematics that you can go into. Now it's all around us. You look at, the shape of your window. You look at roads. You look at your roof line. You look at your table, chairs, everything is geometry, right? So what are we going to learn today is we are going to start with something very, very simple, and we're going to deal with the geometry of triangles. That is required for us to deal with trigonometry as we move forward. So triangles. So there are a few type of triangles that exist in the world of geometry. So area like perimeters and all, till the time you don't know geometry, you don't know their terms, you won't be able to let know area, perimeter. Let's talk about, the triangles first. Now, before we talk about triangles, let's talk about angle. What is an angle? So when two lines meet each other at a point, so let's say there's a line AB, that's the line AB, and there is another line BC. So the common point is point B. When the two lines meet each other at a point, they create something called an angle. So they create something called an angle. Now, the angles in the world of geometry or mathematics are measured in primarily degrees. There are a lot more. There's other uh, variations to the units as well. So you have radians, etc. May not go that direction. It's called angles are measured in degrees. But let's talk about this angle first, right? See what this angle is. So I have a line A, B, and I have a line C, D. When these two lines are joined together, they join together at a point which is called vertex. So the point where they join is called a vertex. Now the vertex is a common point, between the two lines. So if this line was CD and this line was AB, when they join together, I have to merge C and D to give them one common name. So it's my choice. I call it as B, C, or any other alphabet that you want to denote this vertex. I call it as B. My choice. So now CD is merged. This end C is merged with this end B, and I'm calling it as B. And B is at this point is the vertex. And now I have created an angle between the two lines. That is the angle. And this angle in the world of geometry is denoted by the symbol angle. It's like a tilted L with the alphabet that represents that vertex, which is B. So this angle is called angle B. This is the short form or the short name of this angle. There is a longer name as well, which could start from any of the two other sides with this vertex sitting in the middle, which essentially means I can say angle A, B, and D. So I can also write it as people joining in A, B, D. I can also, and I'll change the color of my pen, I can also call it as D, B, A. In both the scenarios, the common part is that the vertex sits in the middle. And the other two alphabets or the other two corners of the angle they are irrelevant. Any order is fine. So either you call it as angle ABD, or you call it as angle DBA, or you just call it as angle B is fine. So there are three major ways that I can call the same angle. I would like to call it as angle B unless there are too many angles given to me. But if it is a simple angle between two lines, I will call it as angle B. That's my way. If you want to call it by the full name, you're more than welcome. Now, every angle is measured. Every angle is measured. So let's say this is 45 degrees. So I will say that angle B is 45 and the degree symbol is a small circle on that measurement on the top. That is the symbol for degree. Angle B is 45 degrees. Now let's understand a few types of angles. Angle types. The first one is called the acute angle. Acute angle is an angle where the measurement of the angle is less than 90 degrees. So let's say this is 65. So angle A, B, C. So angle B is acute angle. Now the next type of angle is called the right angle, which is where the angle, where degree is 90 degrees. Normally, when we represent our angles between the two lines, we draw this kind of a curve, you see here. But when we draw a 90-degree angle, we don't do this. We rather make a small square. So the square tells me that this is a 90-degree measurement. So if I draw something like this, and I draw a square here, and I say X, Y, Z. So my angle Y is 90 degrees. So just look out for this symbol. That should immediately give you the light bulb that it is a 90-degree angle. The next type of angle is where it's gone past 90. It is called an obtuse angle. Now, obtuse angle is an angle which is between 90 degrees and 180 degrees. The next type of angle is called the straight angle. Straight angle is this angle, A, B, C. That is a straight angle. Straight angle means it is a straight line, 180 degrees. So I'll say angle A, B, C is 180 degrees and is a straight angle. And then we have something called a reflex angle. We are now gone past 180, which means something like this. And all these measurements are anti-clockwise measurements. Mind you, because the moment you measure them clockwise, this becomes obtuse. So mind you, all the measurements are anti-clockwise. And the reflex angle is that angle where the measurement, your angle is between 180 degrees to 360 degrees. And then the last type of angle, I'm seeing a lot of chat moving around. Can I ask you all to stop? It's distracting me. Last warning, and I'll call out the names: Karan, Arav, Shadow, right? Rhythm. You guys will be pushed back to the waiting room. That's the last warning, right? Don't even type sorry now, okay? You're just distracting me. Just keep quiet, listen, all right? Oh, good. Now, the last angle is called the revolution. The revolution angle. So what is happening here in the world of revolution angle is that angle measures exactly 360 degrees. Now, technically, it is not, I can just draw a line, right? But think about this, that there is an angle that's gone one full rotation and has landed back here. So it is a 360-degree rotation, revolution that it's made. Earth's revolution around the sun is one full year, one full circle. And that is what we're talking about. One full circle around this vertex completes one full revolution for the angle. Now, we learned of different types of angles. Now we talk about the pairs, right? How are angles distinguished when they sit in pairs, or when they sit together, right, as a group? So the first type of relationship, now I'm going to talk about the relationship between the angles. The relationship between the angles. The first relationship is called the complementary relationship. Complementary relationships are those relationships when two or more angles add up to, join together to become a right angle. So what it means is, let's say you have a 30-degree angle and you have another 50-degree angle. 30 could be slightly more. This 50, 60 could be like this. Let's say there are two angles. Let's say this is angle B, and I'll just call the vertex, to save time. This is angle C. Angle B is 30 degrees and angle C is 60 degrees. So if I add them up, they make 90 degrees combined. So this pair of angle is called complementary angles because they add up to 90. Next one is called the supplementary relationship. They add up to 180 degrees if you've not guessed it so far. They add to 180 degrees. So if I have, let's say, a 30-degree angle, for that matter, and I have another angle, I've joined the two angles here, which is an obtuse angle of 150 degrees. What will happen if I combine them? They end up becoming a straight line. They end up becoming 180 degrees. So when the angles, and it could be more than two. So I'm just taking an example of two. So you could have something like this, where let's say this is 30. Let's say this is 90. And then this is another 60. So now three angles combine at the vertex B add up to 180. So if I change the color of they add up to 180 degrees. So they are also supplementary. The next kind of relationship is called a revolution relationship. And you guessed it right now. A revolution relationship. When all three angles, three more, two, bunch of angles combine to form 360 degrees. Let's say this is angle B. Let's say this is 90 and this is some angle and this is some angle. So eventually all of them combine to make it a 360 degrees. And last but not the least is very, very important, and this will be used in trigonometry, is vertically opposite relationship. So what it tells me is, and this is very important, let's say there are two lines that are crossing each other. Line A, B, C, D. And they are joining at a point, let's say E. So this tells me is that the opposite angles are equal. Always, always. So for example, if this was 130 degrees, this angle will also be 130 degrees. And I'm hypothetically making things up. So if this, and maybe I'll change the color, just so show some difference. And if this is 50, then this is 50 as well. And I talked about the revolution. Add all of them up. Starting from this point, add all of them up. You eventually get a 360 degrees, which is a revolution. So vertically opposite angles are very, very key to understand basic geometry and do a lot of things. Now, the next part is we've understood the angles. We understood the type of angle. We understood the relationship between the angles. And we were talking about triangles today. Let's talk about triangles as well. So how many types of triangles do I know? That's the short form of triangles. How I write it. A triangle, just a symbol. Now, there are a few types of triangles that I'm going to introduce, and we are going to use it as we move forward. The first triangle is called the scalene triangle. Scalene triangle. So the scalene triangle is that triangle triangle. We studied about the angle. Now we are going to study about the tri. A figure which has three angles in it. Tri means three. A figure with three angles is triangle. So it has three angles. Let's say if this is A, B, and C. And as I said, I would just like to call the triangle just by their vertex only to save time. I've got three angles here with three vertices, angle A, angle B, and angle C. Angle A, B, C. None of them are 90 degrees. So scalene triangle is that triangle where none of the angles are equal to each other. They are all different measurements, different values, whatever you want to call. That's called the scalene triangle. And there's a property of triangles when you have different values of your triangle, the different values of the angles, the sides. How many sides do I have? I have three sides. Side AB, side BC, and side AC. So when I have a scalene triangle, all three angles are different and all three sides do not, the values of the three sides are also different. They're not same. The measurements could be different. So I could have said 3, 5, and 6. Let it be centimeters, right? So AB is not equal to BC, is not equals to AC, and hence angle A is also not equals to angle B, is not equals to angle C. None of the angles are equal to each other. None of the sides are equal to each other. So that's called a scalene triangle. With that thought, can you tell me, question now, because I've been speaking for half an hour now. A right angle triangle, with this being 90 degrees, A, B, and C. Is this a scalene triangle? Yes or no? Good job. So you're saying it is not a scalene triangle. All of you have said not a scalene triangle. Very good. Awesome. I love that answer. Could be, could not be. I don't know. Is it a scalene triangle? Is my question. It's a right angle. But right angle triangle is scalene or not is my question. Can I say, I don't know. So you're telling me that this is not a scalene triangle. It depends. If I say this is 60 degrees and this is 30 degrees, now are the three angles same? No, they're not. Mind you, a triangle has a property, and I'm assuming that you're coming from grade 4, 5, 6, so we know the basics of a triangle, right? That the sum of the angles of a triangle is equals to 180 degrees. So if it is a right angle triangle, there are three different angles, right? And I just talked about that, yes, the three angles are not being the same, has to be a scalene triangle. So when you said no, you were all wrong. You were partially correct, I should say. Not wrong, but partially correct. This is a scalene triangle, but it is also right angle triangle. But definitely this is a scalene triangle because the three angles are not equal. I can make, if I write something like this, and I say this is 90 degrees, this is 45, and this is 45, then yes, this is not a scalene triangle. Now, because angle A, B, C, angle A is equal to angle C. So, before you really jump the gun, think about think the depth of the question first, right? Now, that gives me a hint to ask you a question. This angle, this triangle where two angles are same, what is this triangle called? On the chat now. It is called the isosceles triangle. Good job. So they are isosceles triangle. Isosceles. So isosceles triangle is that triangle where two angles and therefore two sides are equal. Now I'll give you a very quick rule of geometry. So let's say, just hypothetically making, don't take it literally, right? So let's say these are two angles A, B, C. So now angle B is 30 degrees and angle C is also 30 degrees. So this is definitely an isosceles triangle. The property of isosceles triangle is, or for that matter, property of a triangle is that when you have two angles equal, their opposite sides, mind you, the word is opposite sides, are also equal. So if I have angle B, what's the opposite side of angle B? Yeah, AC. What is the opposite side of angle C? It is AB. So AB will be equal to AC. Remember that. And there is one symbol in the world of triangles that we use. There's a small line, just like this. There's a small cut on the sides that I make on a triangle. The moment I make that, it simply tells me that AB is equal to AC. So if you have a triangle and you see these kind of lines on any two sides, it simply tells you that they are equal. And let's say if I make another line here, it should tell me that all three of them are equal. It should also tell me, and I'll just take this side off. Let's say you have you've got something like this, and there's nothing else given to you. So one thing that you need to infer is that yes, the sides are equal, cool, but they're opposite angles, other way around. Which is the angle opposite to AB? Hang on, it is angle C. So angle C will be equal to, what is the opposite angle of the side AC? Angle B. They are also equal. So it's a vice versa kind of a scenario. If you are given the two sides, two angles being equal, that means their opposite sides are equal. And if you're given two sides being equal, their opposite angles are equal. Is this clear, everyone? So far, so good, right? Now, we talked about isosceles triangle, we talked about scalene triangle, and you know right angle triangle is any triangle which has a 90-degree in it. So scalene triangle that I talked about above here, this triangle. It is a scalene triangle, but it is a scalene right-angled triangle. So this is 60 and this is 30, my dear kids. So this is a scalene right-angled triangle. Absolutely clear, everyone. And the property of the triangles is that the sum of their angles. So let's say if this is a triangle. Yeah, A, B, C. So angle A plus angle B plus angle C is always equal to 180 degree, not even a degree less, not even a degree more. They add up to 180, irrespective of whether they are scalene triangles, right angle triangles, isosceles triangles, whatever. The last triangle that I just want to cover is called equilateral triangle. Today's lesson is more about me talking, right? So just soak it in, right? Next week we'll do a lot more. Now, right angle triangle is that triangle where all sides are equal. Three sides, they're equal. And how do I represent it? I just cut them through. So this tells me that side AB is equals to side BC is equals to side AC, and the angles are equal as well. Angle A plus angle B plus angle C. All of them are equal to 180, it's being a triangle, and each one of them measures to be exactly 60 degrees. Now, last concept for today that I want to, give it to you is, and next week we'll do parallel lines, that's even more interesting, is a concept of exterior angles. Very important. Let's make a triangle and understand this concept of exterior angle. Let's say there is a triangle, and hear me out loud and A, B, C. And I extend this line. Now, I have three angles in a triangle within a triangle, which is when I say in the triangle, I am now going to use the word interior angle, the angle that sits within the triangle. This angle, and this angle. So angle A, angle B, and angle C. But these are all interior angles of the triangle because they sit inside. And all of them add up to 180. A plus B plus C is 180. I'll change the color of my pen now. I introduce another vertex D, and hence that introduces another angle, which is angle A, C, D. An obtuse angle, A, C, D. This angle is sitting outside the triangle and it is called exterior angle. It is sitting outside, exterior to the triangle. Now the rule says, or the exterior angle theorem says, that this exterior angle ACD is always equal to the sum of two interior opposite angles. Two interior, the word is opposite angle. Let's see, probably I'll sort of change the color. Which angles are opposite to this C? Angle A and angle C, sitting bang opposite to ACD, the exterior angle. So this ACD, the exterior angle, will be equal to angle B plus angle A. A very important concept of geometry. Now I can show a different picture of this angle. And I'm going to ask you a question this time. Let's say this is D, this is A, this is B, this is C. That's the exterior angle which sits outside angle CBD. CBD. Can you tell me what two angles would add up to CBD? Just give me the angles A plus B, B plus C, C plus D, whatever. Just give me that. A and C. A and C is what I'm hearing. There are like 47 participants today. A and C. Yes, A and C. Anyone who hasn't got this, what I'm trying to say is that this angle, which is sitting outside, has two angles sitting opposite to it, A and C. So I'll say angle A plus angle C. Now, another question. Let's say I extend this now. And I ask you, and let's say this is E. Angle EAC will be equal to what? Question. EAC equals to what? All of you. Now, either you write or you write, I don't know. 46 answers. Now, get your hands warmed up. This is not a YouTube video. Good. All right. So this angle, and I'll just sort of draw a figure again. I had this kind of a figure and I extended this and I said this is A, B, C. And I ask you, what is this angle measurement equals to? What is the opposite angles to this angle? Here and here. So it will be angle B plus angle C. I think one of you said, I don't know. I hope you're clear now, right? All right, cool. Now, let's throw some stuff at you now, right? And see where you land. Okay. Let me just draw something. Okay, now let me draw that first, please. Can you tell me the measurement of this X, the angle X here, which is sitting outside? Arav, please concentrate. No, it's not 35. Shaveen, it's not 35. Okay, it is 145. Why? Because I told you whenever I draw a square between the two lines, the measurement is 90. I did not give it to you. Now, so you need to know that this is 90 because no one's going to write it down for you. Now, this angle is exterior. What are the two opposite angles? So this will be 90 degrees plus 55 degrees equals to 145 degrees. Good job. All right, let's do one more. All right, I'm just snippy something up for you and we see where you land. Okay. Difficult to draw figures at times. Can you find me X here? Quick. Use everything that I've taught today and give me X. It is not 94, unfortunately. It is not 94. It's not 84. It is 86. Yes. Anyone who is just going to rush things up, I tell you, is bound to give incorrect answers. I did not have a timing gun on your head. I just asked you to take your time and give it the answer, right? Why 86? Let's quickly understand. This angle, which is sitting outside. Now, understand if you don't understand now, hear me out. This angle, which is sitting outside the triangle, has two angles opposite to it. And let's say this was angle B and angle C. But hang on, I know angle B is 47 degrees. But I don't know what is C. But I know I see these two beautiful lines. And I told you when you see some kind of a lines on the sides, just make their opposite angles equal. So which means if this is 47 and I've got two lines here, the angle opposite to this line is this one and this line. So these two angles are equal. So this is also 47. And X is now for X, these two angles, 47 degrees each, are the opposites. Add them and you get your answer. Is this clear, everyone? Everyone, is it clear? Okay, okay. Now, one more thing. Geometry is tricky, right? I tell you. If I do something like this and I say two lines, it still means the same, my dear kids. It still means that they are equal. So don't, get confused. Oh, it was just one line. Now this is a two line. What does that mean? That actually simply means they're equal. Finish. If I draw 3 lines, still means they are equal. 4, 5, 6, they're equal. They won't do it. But don't worry. Just count the 9 lines. Count the cuts. And they're equal. With that thought in mind, let me pull out a snippy of another figure and see what you do. Take your time, and there is no rush to the finish line. I still have 2 minutes, but it's okay. Go for it. Give me the value of x, please. You need to do a few things here. "56 degrees" is the right answer. 56 degrees is the right answer. Good job. There are n number of ways of doing this question. N number of ways. I can show you a few. Maybe, how my brain's working today morning. These 2 lines are equal. That means these 2 angles must be equal. I just told you, right? Now, these 2 angles are equal. I mean, this is my way of doing it, and another sort of viewpoint to solving geometry. My exterior angle is equal to the sum of 2 interior opposite angles, right? So let's say this is y and this is y. I don't know them as of now. Now tell me, if I just draw a line like this, and this is 118 degrees, what would be the measurement of this angle here? Can someone tell me? Because it's a straight line is 180 degrees, and I've got 118 here. So this will be, yes, you're right, 180 take away 118 will be 62 degrees. So which essentially means that this y here is 62 degrees. So this being equal, they being equal, this is also 62 degrees. Now I have a triangle with 62 degrees here, 62 degrees here. Can I not find this x? Add them. All of them add up to 180 degrees. And the algebra that we know today will tell me that x is what, 56 degrees. Yes, that's the answer. And I did not make use of the interior exterior angle sort of story. I did not need it. So with that thought in mind, I will stop my lesson today here. Okay, let's do one more maybe. All right, let's do one last question and before we go. Right, let's do one. And I will leave up to your wisdom to solve it and tell me what the answer is. Here you go. All right, on request, one more question. Can you find me x degrees? Use everything that you know to solve this. A few have left already. Last question and one last minute. I haven't seen the right answer yet. None of you. Yes, Tanchika, good. 155. Thank you. That's the right answer. Arv, yes, 155. That's the answer I'm looking for. Yes, 155 degrees. Good job. Good job. Awesome. With that, I will rest my session to peace, my dear kids. And I will see you back next week with more fun. And we are going to do parallel lines, right? We'll have n number of examples there, right? And we'll have a lot more fun. All right, cool. Thank you very much for your time, and I will see you back. Have a good one. Enjoy your weekend.